Here we have a definite integral. That means an integral between two limits. So when we have an integral bound by two limits, we carry out the integral, but we don't add the constant at the end. We substitute the two limits. So let's look at the integral. And before that, let me remind you of an integral you should know. So the integral of 1 over x dx is the natural logarithm of the modulus of x. So you need to know that. And what we have is 1 over 5x plus 3. So it's a function of x. So the integration is actually the natural logarithm of the modulus of 5x plus 3. But then we need to divide by the derivative of 5x plus 3. We do that because of something called the reverse chain rule. So again, 1 over 5x plus 3 will be the natural logarithm of 5x plus 3 divided by the derivative of 5x plus 3. Okay, so that's your answer, and we're not going to say plus a constant because we have these limits here. So what we're going to do is we're going to calculate this log using these two limits. So we're going to substitute the upper limit first, and then we're going to substitute the lower limit. We're going to substitute the -7. So the answer will be 1 over 5 ln 5 times -1 plus 3 minus 1 over 5 natural logarithm of 5 times -7 plus 3. Now, remember there is a negative sign here. You need to subtract. So you substitute the -1 first, and then you substitute the -7. So the upper limit first, the lower limit second. And between the two, you need a negative sign. And remember, these signs, these vertical lines, these are the modulus. So the modulus function takes the absolute value. So this is the modulus function. So the modulus of a negative number will give you a positive number. So it looks like we're going to have negative numbers here. So let's calculate that. It's 1 over 5 ln modulus of -5 plus 3 is -2 minus 1 over 5 natural logarithm -35 plus 3 is -32. Now, when you take a modulus of a negative number, you end up with the positive number. So what we have is 1 over 5 ln 2 minus 1 over 5 ln 32. So watch out. You can't take the log of a negative number. That would be unacceptable. If you were to find ln -2, that wouldn't work. Okay, so make sure you use the modulus function. Now, if you want to simplify this, we can take these coefficients and turn them into powers. We use a particular property of log. We know that n log x equals log x to the power n. And the natural logarithm ln is just log to the base e. So I can now rewrite this as ln 2 to the power 1 over 5 minus ln 32 to the power 1 over 5. And when you have a difference of two logs, there's another property you can use. So let me write that there. We can say that log A minus log B equals log A over B, provided that we have the same base. So we can turn this subtraction into division. So we now have ln 2 over 32 to the power 1 over 5. Now that's the same as saying ln 1 over 16 to the power 1 over 5, and 1 over 16 to the power 1 over 5 is simply 1 over 2. So you could say that's minus ln 2. So that would be your final answer, negative ln 2. Now you could leave it like that. I don't think you could leave it like that. That probably wouldn't be acceptable as your final answer, but it is correct. This is definitely correct. But your final answer would be negative ln 2.